Namaskar friends. So here we are to discuss lecture number 4 in our discussion in week 2 related to value engineering. As you are well aware that we are discussing the various concepts of value engineering. Already we have taken 3 lectures on value engineering. The basic concepts have been discussed, the historical perspective of value engineering has been discussed. What is not value engineering has also been discussed. What is value engineering has also been discussed. We have also discussed why the products have poor value or poor value functions. Then we came to the functional analysis. We have seen the value engineering job plan, what is a systematic approach for solving any problem using the concepts of value engineering. Also we have seen, if you remember, the functional analysis, in which we have seen that how to define or identify a function using a verb and a noun type of definition. We have also seen examples of basic and secondary functions, and if you remember, in basic and secondary functions we have taken example of an electric kettle and a mobile phone. That for a mobile phone, what are the basic functions and what are the secondary functions. And in the last class or the last lecture we stopped at the function cost relationship, and we will start our discussion today from the function cost relationship and try to understand the details regarding the function cost relationship and how this type of a tabular arrangement of functions and cost can help us in our overall objective of improving the value of the product. Now this was the slide that we have seen last time. The only thing that was missing in the slide was this 30. So 30% is the profit for that product. So we can see, if again we see noun and verb type of definition: lead, make marks; wood, protect lead; metal cap, hold eraser. So we have divided the wooden pencil into its individual components and the processes that add to the cost of the product, and the cost of the product is 3.5 rupees, and which is added up here, and profit is 1.5, and the price of pencil or selling price of pencil is rupees 5. So here you can see, from value engineering point of view, we have components and the processes like lead, wood, metal cap, eraser, shaping of wood and printing. 2 processes, shaping and printing, and the material, that is lead, wood, metal cap and eraser. So all these add up to the cost of the product. And if you can see the functions, or during the functional analysis chapter we have seen that we have to identify the function from the very beginning, and we have to use a noun and verb type of classification for a function, or noun and verb type of definition for a function. So here you can see, for each and every, even for the processes as well as for the materials, we have 2 word definition: make mark, or we can say make marks; protect lead; hold eraser; remove marks; provide grip and display information. So if you take a pencil and just look at it for 5 minutes, you will be able to relate to all these aspects. That is, the lead is the main component which is used for making marks. Wood is used for protecting the lead. Metal cap is used for holding the eraser. Sometimes you will have a eraser at the back side of the pencil which is held by a metal cap. Then there is a eraser which is used to remove the marks. So what we can gain out of it? Just give a thought to this particular analysis and think that what we can derive out of it. We have to find out that how we can improve the value of this pencil by redesigning, or you can say taking decisions related to the customer needs, or thinking of the alternatives which can help us to achieve this desired function of making the marks on a piece of paper. So if you see here, we see that most of the money, maybe 60% of the cost, is only going into the secondary functions. Only 10% is the cost which is actually making contribution for achieving the intended function or the desired function. Now what should be our focus as a product designer or as a value engineer? Our focus should be this cost that is going. So this cost is the total cost of the price that the person is paying. A person is paying rupees 5 to buy this pencil, out of which 1.5 goes to the seller or the retailer, and 60% cost goes in this material, and only 10% is satisfying the basic function or the primary function of pencil. Now you can see how much is the scope of saving money. Now from this information we can very easily understand that if we are designing a pencil to be used for, we can say, executives in the conferences which are organized in 5-star hotels. So in those particular conferences nobody may be interested in reading what is written on the pencil or displaying the information. For example, in many pencils we will see a message, save trees or save girl child. So maybe that may be relevant to young minds or the school going children or the college going children, college going students, teenagers. May not be that relevant to an executive who is mature enough to understand all these things and who has gone to a hotel to attend a conference. So if we are designing a pencil to be used by the executives in hotels for attending during the conferences, or we can say during the discussion stage they have to use that pencil, maybe we can avoid the printing, which is adding cost to the product. But in case the pencil has to be used by school going children, so different color plots or cartoons on the pencil will definitely attract that customer and would be kind of adding esteem value to the product. So when we are designing a pencil for a student who has to go use the pencil in a school, or for young children, definitely we will go for printing. Similarly, in a hotel, if the pencil has to be used during the conference, maybe nobody may like to use a eraser at the back end of the pencil. Some people may love to use a separate eraser for that purpose. Those cases, maybe metal cap and eraser can easily be avoided. This is an example to understand, very basic example to understand that how functional analysis will help us to take decisions related to the product design and save money for the organization and add value to the customer who is using that product, or add value to the product for the customer who is using that product. So this is very simple example of functional cost mapping or functional cost evaluation of any simple product. Similar type of studies can be done for maybe big buildings, design of bridges, design of highways. So maybe all those aspects can also be analyzed using the same principle, and this has led to savings maybe running into thousands and millions of rupees. So that is the kind of savings potential that this technique possesses, and if product designers make use of the principles of value engineering during the design stage, they can lead to substantial savings for the company. So let us now further, we can say, scrutinize this function cost relationship and use another tool which is widely used for function analysis, which is the fast diagramming approach. So let us see how a fast diagram looks like and how it can be used by the designers to take decisions which are more logical and which are going to lead to success of the product in the market. Now just a brief overview of the functional analysis system technique, the fast diagramming approach. Charles Bathway developed fast diagrams in 1964, just the historical point of view. Fast diagrams are function oriented, these are not time oriented. In network analysis sometime or during in schedule graphs we plot on a time scale, but here we are not plotting on a time scale, but we are plotting in respect of the functions. Fast permits people with dissimilar technical backgrounds to effectively communicate and resolve issues that require multidisciplined considerations. So as you know that value engineering is not only related to mechanical engineering or civil engineering or electrical engineering, it can be related to any aspect of engineering and science as well as management. So for any project team, I have told you that there will be people from diverse backgrounds. People may be there from marketing, people may be there from sales, people may be there from finance, people may be there from legal cell, people may be there from environmental department. So you will have a diverse team. So fast diagramming approach will help you to just put everything on a piece of paper, every information related to the functions the product has to satisfy, and then people can give their ideas, brainstorm. Even brainstorming is function based brainstorming in case of value engineering. So all functions will be placed at their proper places in a diagrammatic manner, and then the discussion can take place related to the improvement of the project or the process. So it will help to document the things properly. Fast builds upon value analysis by linking the simply expressed verb noun functions to describe complex systems. Now suppose we have to analyze a complex product, for example an aircraft. So for aircraft the basic function can be carry passengers, but in order to analyze it from the value engineering or value analysis point of view, we need to break down the complete aircraft configuration into its individual components, and some of the components will have interacting functions also, and then for those functions we need to analyze that how the functions can be clubbed together or eliminated or maybe modified in order to solve the overall objective of cost consideration or overall objective of cost justification. So fast will build up break down the complex system into smaller elements which are easier to analyze. We will see fast diagram with the help of one or two examples, and then it will become absolutely clear that how a fast diagram would look like and what type of decisions we can take based on the fast diagramming approach. Now you can see fast is not an end product or result, but rather a beginning. So what we will do, it is just representing the complete product into its individual components and then trying to understand the function of each and every component, so that we can have a you can say creative view of what else can do the similar type of task and what can be done to avoid or maybe some problems that are existing in the system. It can also help us to identify areas where new technological developments have taken place and which can help us in overall improving the value of the product. Maybe in a complete system, maybe in an overall automobile, there may be a material which has been developed which is impact resistant. So when we do value analysis of an automobile, we will try to include that material in the front side of the automobile so that the crash worthiness of the automobile improves and the value to the customer also improves, because now the automobile has become more safe for the customer and he may like to buy that kind of an automobile without any further increase in the cost. So piecewise or piecemeal, when we do the analysis for each and every component, it becomes a successful analysis, and many of the components which are redundant can easily be eliminated. Similarly is the case with human body. Maybe if we go to the evolution, I am not an expert of that, but earlier the body has evolved and the unnecessary parts in the body have now been eliminated because of the rules of evolution. So whatever is not required has to be eliminated. Similarly in a product, when we will do step by step analysis and we will do the analysis for each and every component of the product, we will understand that there will be certain parts which are not at all required in the product and can easily be moved out, and subsequently leading to improvement in the value of the product. So we will try to understand the fast diagramming approach and how a fast diagram looks like in the subsequent slides. So you can see fast diagram, it is a tree type diagram, visual layout of products functions. We will see with the help of an example. It starts with the basic function and builds to the right with supporting or secondary functions. So it will list all the primary as well as the secondary functions. Why do a fast diagram? Just one line answer. Understand the functions to be eliminated or improved to deliver the basic function. So these are the 2 or 3 objectives for fast diagram. We need to understand what are the basic functions which the product should satisfy, and what are the functions which are redundant and which can easily be eliminated. So or I should not say eliminated, sometimes some functions will be combined together and made a third function which will be helpful to us. This is a standard FAST diagram, functional analysis system technique diagram. You can see there are two lines. Let us see, this is line number vertical line 1 and on the right hand side vertical line 2. These are the scope of study. Whatever functions are there will be, this is a, you can say, boundary lines for the study, and these all functions will be listed inside. If you see the blue lines, from this side we will ask how type of questions, how this function is achieved, then next how this function is achieved, next how this function is achieved, and from this side we will start asking why, that why this function is required because of this, why this is required because of this, why this is required because of this, because here you can see why do you do this, how do you do this, when do you do this, you also do this. So when means it is not in time domain, but when is that if this you are doing, when you will do this, or during, it is giving a vertical scale that when this particular thing will be done. So it is fixing up that if with this particular function these things are also going on simultaneously. That we will try to understand with the help of the diagram. But first let us see the overall picture of the diagram. As I have told you in the very beginning related to the concept of value engineering, that 5 W's are very important. That is, questioning technique is used to identify the problem. So here also we are using 3 important questions, that are how, why and when. So from one side we are asking how type of questions, from other side we are asking why type of questions, and then when that particular function is done, that is also listed in the FAST diagram. So whenever you see any FAST diagram, these are the 3 directions in which you have to focus: direction, which is horizontal direction, and the vertical direction. And when you move from left to right, you have to ask how type of questions, and when you move from right to left, you have to ask why type of questions. So let us now see, and function as written here is active verb plus measurable noun, which we have already discussed in the previous class, where we have seen that, for example, for a watch, the definition of function can be show time, that is a verb and a noun. Similarly for we can say camera, record information, again it is verb and a noun type of definition. So wherever function is written, you will get two word verb and a noun definition of that particular function. So this is the overall skeleton of a FAST diagram. Now we will try to fix some example in this diagram. In this diagram, when we will try to see that how a FAST diagram can be drawn for a pencil or for an overhead projector. Let us go to that. This is again just a skeleton. Ask how, ask why, already I have explained, and there we can see or logic can also be used, and logic can also be used. So maybe that we will try to understand when we see the example. This is again how and why type of questions. So when the customer needs are satisfied by the functions that the product is providing, it means the product is going to be successful. So FAST model is complete when the customer needs can be mapped to the functions. So if the customer, maybe if you draw a FAST diagram, maybe it can be an assignment to you that you draw a FAST diagram for the washing machine. So somewhere in between you will see a function wash clothes. So wash clothes is a requirement of the customer, and if it is getting satisfied, it means that the overall representation of the functions on the FAST diagram is successful. Now let us try to understand. I can understand that it is not that easy to comprehend until and unless you see a particular example. So we have taken 2 examples to clarify this. Now here you can see this is a pencil FAST diagram, or you can say FAST diagram for a wooden pencil. Now you see there are how type of questions, why type of questions, and then this is one function and this is another function. This can be higher order function, this can be lower order function. So first is hold pencil, and on this side, on the far left side, on the left scope line, you have keep records. Now let us take example and ask ourselves how and why type of questions. We start from here. How we can keep the records? By maintaining the information. How we can maintain the information? By recording the information. How we can record the information? By making the marks. How we can make the marks? By depositing some medium. Medium can be pen or a pencil. Right now we are not clear that we are going to use a pencil, but maybe we will deposit the medium. How we can deposit the medium? Medium is lead or ink, something. By applying the pressure. How we can apply the pressure? By transmitting the force and by supporting the lead. So both things have to be done in order to apply the pressure. So there that or and logic will come into picture, that you have to transmit the force also and support the lead also. Then how you can transmit the force? By accommodating the grip. And how you can accommodate the grip? By holding the pencil. So we can say higher order function, keep records. Lower order function, maybe we can say hold the pencil. So by holding the pencil we can keep the records. So this is, you can say, we can sometimes call it as a critical path also. So from how type of questions from left to right, we can see what is the relationship among the various functions, or what is the relationship among the various you can say methods with which we can achieve our higher order functions. So it is not methods, basically we can call it functions only, that what are the functions which will help us to achieve our higher order function. So here you can have an idea. If you start from right hand side, start asking why type of questions. Maybe you can try it on your own. If we start why type of questions, you will see why should we hold a pencil? Why should we hold it? In order to accommodate the grip. Why should we accommodate the grip? Because then only we will be able to transmit the force. Why do we transmit the force? In order to apply pressure. Why do we apply pressure? To deposit the medium on a piece of paper. Why do we deposit some medium? Medium means, again I am revising, it is lead or ink. Why we are depositing the medium? In order to make marks. Why do we make marks? In order to record information. And why do we record information? To maintain the information. And why do we maintain the information? For keeping the records. So if we move from right to left, we have to ask why type of questions. If we move from left to right, we have to ask how type of questions. And when we will protect wood, it will improve the appearance, and improve the appearance, it will display the information. So at this level only, when we are using wood, these things are also happening at the same time, because we are using wood for covering the lead. So wood can have the other functions also. It will improve the appearance as well as it will display the information. Suppose we are using plastic here, then also there will be some additional functions or secondary or tertiary functions that may come into picture. So from here we can see there is another path also which is related to the eraser. Secure eraser, apply pressure, absorb medium, remove marks, correct information. So similar type of, because this is the pencil, as we have seen in the first slide today, pencil has a metal cap as well as a eraser. So what does that mean? That means that, what does that mean? That means that you have a secondary purpose also. So primary is to make marks, but secondary is to help erase the marks which are may not be correct. So we can see now whether this is required or it is not required. If it is not required, you can even eliminate this particular function of the eraser and the metal cap. So fast diagram will help us to identify which are the functions which are not required. This is again an example of the overhead projector of fast diagram. Again you can see from the left hand side you ask how type of questions, right hand side you ask why type of questions. This is a fast model for overhead projector. Let me just go from one direction to other. If you start, higher order function is to convey the information. How we can convey the information? By projecting the image. How we can project the image? By generating light. How we can generate light? By converting the energy. How we can convert the energy? After we receive the current. How we will receive the current? When the current will be transmitted. And if we start from the right hand side, start asking why current is transmitted? To receive the current. Why do we need to receive the current? To convert the energy. Why do we convert the energy? To generate light. Why do we generate light? To project image. And why do we project image? To convey information. And when the image is projected, we have to ensure allow safety, facilitate portability, focus image, support image, amplify image. So when the image is projected, these are the other functions which also need to be satisfied. So here you can see, when we convert the energy, it will generate heat. When it will generate heat, the heat needs to be dissipated, and it will, when the heat will dissipate, maybe with the help of a fan, it will generate noise. So now you can see for yourself that we have taken a very simple example of a overhead projector that everybody uses, and use the fast diagramming approach to break down its individual components and try to understand the function of each and every component. Now suppose with the technological advances, we come to know that there is a source of light which is available and which does not produce any heat. All these things can be eliminated because our function is generate light. So light has to be generated. As per the existing technology, there is a source of light which also produces heat, which has to be taken away, and for that you have additional functions in the product. Now suppose we know from our background that there are sources of light which do not produce any heat. All these functions will be completely eliminated and your product will become simpler product. There would be no noise, there would be no heat, so it would become a more valuable product for the organization as well as for the customer who is going to buy the product. So we have tried to understand that how the basic fast diagramming approach can help us to list out the functions of the individual components of a structure or of a product or of a assembly, and try to eliminate or redesign or reinvent the product in such a way so that our product adds value to the customer. So that is the basic concept of fast diagramming. We have seen that pencil can also have certain modifications in order to suit the customer requirements. Similarly, the overhead projector can also be redesigned in order to suit the customer requirements. So with this we come to the fundamental or the basic aspect of fast diagram, that what are the benefits of fast diagram. We can now, I think all of you can try to find out a product. One, I am giving you washing machine. You can take a washing machine, whatever you are using, and try to make a fast diagram for the washing machine, and then you will see that fast diagram will help you develop a shared understanding of the project. It is a common you can say knowledge for everybody. Everybody can use the same fast diagram and try to understand the functions of the product. Identify the missing functions, define, simplify and clarify the problem, organize and understand the relationships between the functions, identify the basic function of the project, process or product, improve the communication and consensus, and stimulate the creativity. So all these are the advantages of the fast diagram approach. If you are able to construct a fast diagram for the product that you want to value analyze, all these advantages will automatically accrue, and you can easily lead to maybe identifying there are some missing functions, you can add those missing functions. There are some additional functions which are not required, you can eliminate those additional functions. There can be functions 3 or 4 which can be combined together into a single unit. That can also be done if you know the fast diagramming approach, and it will stimulate, as it was given in the first or second slide, that it is not the end product of your value analysis, it is the beginning. It will help you to create new ideas. It is just the representation of the complete product in its functional form or as per the functional analysis. So I will advise, I would request, I would ask all of you, I will urge you to make a fast diagram, maybe 1 or 2 fast diagrams for different products that you see around you. So with this we come to the end of our discussion on functional analysis and fast diagramming approach. We will have our last session on value engineering, which will be related to the various case studies which have been performed or which have been reported are available, where the successful implementation of value engineering has been shown. So now we will go further down into the application areas of value engineering. Thank you very much.